What is the electron configuration for yttrium? Yttrium, if I were to write the noble gas configuration, it would be argon, krypton.
No, wouldn't it be radon?
Yttrium is by number 39.
You know.
4B1. Are you with me? So now,
It has 4.
that is the, like your 3D, this is your 4S. Yes or no? This is your 4S, that is your 3D. So, why do we even talk about valence electrons? Because they're the ones that are responsible for all the reactions that we see around us. Whether they make artificial clothes for you, whether they make this paper or the plastic, anything. It's how reactions take place. Is that right? So in every atom, any chemical reaction, why do you have a new product when you mix two things? It's because the electrons are rearranging. And which electrons primarily rearrange? The valence electrons. Okay. So now, remember we didn't consider the D block? So supposing an element wants to react with yttrium. Alright? Yttrium has 2 valence electrons here. Is that right? There are 2 electrons that are going on in this region of space, moving clockwise and counterclockwise. Yes or no? There is 1 electron in one of these narrow d orbitals, and it's going around in them. Is that right? Supposing something reacts with yttrium, is it easier for it to pull the electron out from 4s or from 3d? 4s is a broad region of space. If I'm putting my hand in and trying to grab an electron, 4s. Is that right? Yes?
It's a bigger space, so there's more outside.
Is that right? Guys, if I'm trying to grab an electron, which is a more spread out region? Is it the 4s or the 3d? So, which is the number of valence electrons for any element in the d orbital? It is the s orbital. There are a number of kids, those 2 boys, I don't know if you're following along. Okay? Not only are you distracting yourselves, you're distracting everybody else in the class. And this is material I'll test you on. I need you to know this. Alright? I don't think your textbook will explain this. I'm pretty sure you cannot find it in your textbook. So for any element in the D block, what becomes the electron that can be used in a reaction? It is the outermost s orbital electrons, because it is spread over a greater region of space. Does that make sense? So even if it's yttrium, the number of valence electrons will be 2. Now let's look at iron. If I were to write iron's electron configuration, it would be argon followed by 4s2 is it 3d6?
Yes.
Correct?
Yes.
Now, so how many valence electrons does it have?
2.
2. So if iron is making a +2 electron configuration, are you with me? Which 2 electrons will be last?
4s.
The 4s2. So the remaining will be argon 3d6. Are we good?
Yes.
You won't write argon 4s2 3d4. Does that make sense? You will write argon 3d6. Are we understanding? Now, we often see compounds in nature that are Fe plus 3. Are you with me? And so we as chemists are baffled with I can understand the Fe plus 2, but why is there an abundance of Fe plus 3 compounds? That is because if it is Fe3 plus, the configuration becomes 3d5. What is it that elements love to have?
Oh, why did you write 4s2 then? 8.
I'm sorry. Yes, sorry. 3d5. Why do they have a 3d5? Why do they love that? Because that's half filled. So like I said in my other class
I don't
too,
get it.
when the sun, the earth goes around the sun. Is that right? I was taught this way long ago by my professor. Alright? Why does the earth go around the sun? Yes, you have the gravitational force, it keeps it in its place. But I really don't know why it is set up that way. I just know the how behind it. Is that right? Why does the flower look the way it is? I don't know.
Genetics.
Alright? Genetics, yes, it's the how of it. Is that right? Is that right? So there are many questions. Why is the half-filled electron configuration preferred? I don't know, it offers stability. And elements prefer stability. And therefore, even if it's in a narrow region of space, that one electron does get lost. Are we good?
It's closer.
So now let's go to some of the exceptions. Kids kept asking me what were the exceptions. Is that right? If you were to write chromium's orbital diagram, you would have thought it is 4s2, 1, 2, 3, 4. Is that right? You would think it's 4s2, 3d4, followed by it's argon. Is that right? And that will be the orbital diagram. But does chromium look like this? No. How does chromium look? It looks like this. Is that right? So what is chromium's electron configuration? Argon, 4s1, 3d5. It's one of the exceptions that we are learning about.
Wait, so chromium or
Argon is just a noble gas notation for it.
Oh, yeah.
All right. So which are the elements that will break the rule? Any D4 and D9 will break the rule. Where will they get that extra electron from? From the s orbital. Are we good? Now, silver, what will be the electron configuration for silver? Silver will be krypton, 4s1, right? Krypton 5s1, sorry. 5s1, 4d10. That will be silver. Does it make sense? And then molybdenum will be krypton 5s1 4d5. Do we understand? And stop this one also.
Yes.